Okay, let's do this. I feel like they're, after grading your quizzes, even though class average was like, what did I say, 84 yesterday, so it wasn't that bad at all. I still feel like there's some disconnect between these formulas and what to plug in. All right, huge disconnect. So I'll go over one thing, and then I need you guys to talk to me and say what else is keeping people from being successful on these formulas. All right, AN, right here, AN, either formula for geometric or arithmetic. That is an actual term from the sequence. Okay, that is an actual term. So if I throw up here, I'm just easy one, 2, 4, 6, 8, 10, 12, so on. Arithmetic. AN, any of these terms except for the first. Any of the terms. Not its position, any of the terms. So let's say I plug in 8. That's an actual term. A1 shouldn't be a big deal. N now. Where's 8 in the sequence? Where is it? That's what goes in there. Not 8 again. Whatever term you just plugged in, the fourth term. Same thing down here when I have AN and this N right here. All right. What other disconnect is there using this formula? Because I'll be honest, on the quiz, and I know I'm giving stuff away to people who haven't done it yet, but I asked something like find the, I'm not going to give out the actual term, but like the 105th term. And I had people plugging in 105 here. 105. Okay? No. You're finding the 105th term equal to whatever the first term was. Now what do I plug in for n? See, this is the disconnect we're having. N is the number, the term spot I'm trying to find, which is 105. So I'd be plugging in 105 for n. Minus 1 times whatever the d value is. All right. This formula finds any term in the sequence. Okay, along with some other stuff, but mainly it finds any term in the sequence. All right, I wish I could stop and review all this stuff all over and have some group time, but we can't. We're already back a couple days anyway, so. Got your formula sheets, calculators already. Here's what we're doing today. I'm gonna take those first of all, before I get in, anybody questions on the assignment last night? Answers are gonna stay up there forever. If you didn't try it out last night, you still wanna study for it. Any questions? Thinking there's any correlation between grades and how much we practice? I think so. All right, then let me get into today's stuff. We're going to take our geometric sequence. 3, 6, 12, 24, 48. Why is that geometric first before I start anything today? Why is that geometric? Nope. Here we go. We're going to force some people here. What makes that sequence geometric? Okay. 3, Campbell, what makes that sequence geometric?
I'm not sure.
Okay. What's the pattern? 3 to 6.
It multiplies by 2.
What's that word you said by 2? It does what by 2?
That would be geometric.
Why?
Is it multiplies by 2?
Multiplies by a number. The 2 she just gave me, I call the what of the geometric sequence? The number 2 there. 7. Nope. I might just take people who are not here. 5. Elliot, what do I call that 2 I multiply by? Common ratio. What letter represents it? R, correct. All right. If I wanted to, and I said find the 50th term, if I ask you to find the 50th term, we should be able to do that using the formula from yesterday. And I'll just leave it at that. I don't have time to go back into it. What we're going to do today, find the sum of the first 50 terms now. So 3 plus 6 plus 12 plus 24 and so on, all the way to the 50th term. Add them all up for me. Remember, that's called a series. When I add them all up, that's called a series. Before I do that, practice using our sigma button on our calculator. Ready? Find the sum. I'm not asking you to do this by hand. I'm asking you to do this right in your calculator now. So grab your calculator. If you have one on you, remember where the sigma button is. You guys can go right ahead of me there if you want to try it out on your own. And if you don't have a sigma button on Friday, be ready to do it by hand. Okay, be ready to do it by hand. Sigma button. So I got n, or you can put an x we talked about, equals 1 to 12. Okay, I'm doing this with you for this reason. See that parenthesis they gave me at the beginning? Remember, all of this has to go in there. All of this has to go in that one parenthesis. I cannot bounce outside. So 3 times 2. Now watch, I'm going to keep it all in there, not outside, raised to the n minus 1. And we should all got 12,285. Make sure you do. Make sure you have 12,285. Anybody not get that in their calculator?
Where's that symbol again?
Alpha window. Number 2. Okay. So just a quick review of that. Anybody not get it on the calculator? All right, let's add these up now. I'm going to take a geometric sequence and add up all the numbers. If you remember, when I do that for arithmetic, you guys remember building your own sigma for that? When I add up the terms in an arithmetic sequence, I got to build my own sigma. Not anymore. Look on your formula sheet. We're actually going to use a formula instead of doing a sigma. It's the last formula on there, which says geometric series. Everyone see geometric series. You do not have to build a sigma. You use the formula. One by one, here we go. S sub n, that means S for sum. Hey, S for sum. S is for sum. All right, that's what it means, the S. Sum of n means, I don't know, how many terms you're going to add up. That's what the n is. You're going to find the sum of the first 10, 20, 30. That's what goes in for n. So n is the number of terms I'm adding up. All right, somebody else, keep reading it for me. 10. So we have a 10 or no? 10? Okay, no, not here, so I'll just keep doing it. A1, which is my first term. Plus or minus? Minus. First term times, all right, keep going for me. 6. R, which is what? Okay, so I better know what I'm going by. What am I multiplying by? Raised to, Emily, keep going. N, what's N again?
The thing. I forget the name, but I know what number it would be. It's not the number. The common ratio. No, it's not.
Is R.
And then the N would be the term.
It's the same as this right here.
Yeah.
So what's that mean? That's the number of terms I'm adding up. Okay?
Yeah.
That's what goes there. We're all clear, everybody else? Number of terms I'm adding up, and then all over what?
Me?
Yep.
One minus R.
What's R again?
Common ratio.
How do you find it?
Whatever it's multiplying by.
Whatever you're multiplying by. Quick question. What if I don't know what I'm multiplying by? I can't figure it out. I'm clueless. I know it's geometric, but I have no idea what it is. Alexa. Ryan? What do you mean?
Take the term before and divide it.
Take a term and take the term before and divide it. There you go. You get your R value. It's fine. Okay, you ready? Let's go to number 2. Find the sum of this geometric series. Okay, I get it. I know we're going to use the formula. I get it. But here's the point. Here's the sticking point we got to get over. What's all that mean that they're giving you? What does all this mean? A1NR. Yeah, hold on. You can plug it into the formula. Perfect. Great job. But what are they telling you here? This is a hump we need to get over and start understanding all this notation. 16, yes, no? No, okay. A1, they're giving me the first term in this sequence is what? 2. 2. All right, let's keep going. 14. Perfect. N equals 10. That tells me I'm about to add up 10 terms in the sequence. The first 10 terms. That's what N's telling me. Find the sum of the first 10 terms. And R equals 3. 11. Perfect. I'm going by threes, multiplying by 3. So if you want a visual of what this sequence looks like, 2, 6. How do I know it was 6? Oh, that's what R means. 18. 54. So if you want to go into what I call desperation mode, which is I have no idea what's going on, you can at least list out the entire sequence and add them up in your darn calculator. If you have to go into desperation mode. I don't think many of you should ever go into that land. All right, or take that trip. Okay, but that's what it is. If you don't know what the heck you're doing, at least you know what this means, and you can write out the sequence instead of using the formula. I'm better than that, you're better than that. So we're going to use the formula. So we're going to find the sum of
10.
4. 4 in the house? No, perfect. Sum of the first 10 terms. That's what that notation means. Sum of the first 10 terms. It's equal to, let's go to our formula now. 22. Big dog back there. A1 minus 2. What's your R value? 3. What are you raising it to? 10. How many terms we're adding up? What's on the bottom, Tomer? 1 minus 3. Done. Please plug that in all at once in your calculator. Don't try to do the top and the bottom. Something might go wrong. Get a fraction template, alpha y equals, and then plug in the top and the bottom as you wrote it on your paper. $59,048. Questions? All right. Find the sum of the first 8 terms of this sequence. Desperation mode, right? Find the pattern and just write out all 8 and plug them in your calculator. We're not about that life, though. Yeah, thanks. Yeah, you and my first period kid who sits there. How do I know this is for? Whoa. Friday on test. This is going to be a random question. Anybody see the word geometric up there? Yeah, me neither. So on Friday, as you do this, how are you going to identify that this is geometric versus arithmetic? Because I'd approach it totally different if it was arithmetic. How do I know that bad boy's geometric up there? Again, you got 3, negative 12, 48, negative 192. How do I know that's geometric? How are you going to know on Friday? 17?
The sum.
Well, I could find the sum of an arithmetic too. I want to know, how do I know this is a geometric problem versus an arithmetic?
Oh, because it's not addition in between the two.
What is it?
Multiplication.
By what?
-4.
Good. Perfect. That's how I know it's geometric. Multiply by -4. So now if you want me to find the sum, okay, it's geometric. Find the sum. Go to my formula sheet. Here we go. Sum of how many terms? N? 8. Convenient, huh? No 8? Okay, we're finding the sum of the first 8 terms. You didn't want to answer that?
What?
You didn't want to answer that?
Oh,
No.
is it my number?
Number 8.
Or
It's all right. You can do it now. Here we go. First term.
3.
3 minus first term.
3.
Okay, what are you going by again?
-4.
Times -4. And we're raising it to what again? N, number of terms I'm adding, adding up. 1 minus what here?
-4.
Better be careful. Why do I say be careful?
Because
What, Elliot? Yep. Yeah, it's going to be not 1 minus 4, 1 minus a negative 4. So that should be positive 5 on the bottom. Go ahead. Choice 3, negative 39,321. Going. Again, you hit desperation mode, go right out the full sequence of 8. All right, this one's going to be a little tougher. Sorry, buckle up. Is it very clear what formula you need here based on the directions, right? I'm not hiding anything arithmetic or geometric. I'm saying find the sum. Oh, problem. When I ask this question right away, find the sum of the first problem. Yeah, I don't have an n value. That stinks. Right, I don't, I guess we could go, what, 2,000 minus 2,000 times 1/2 raised to the, I still don't know, over 1 to the 1 minus 1/2, right? I can do that, but I don't know what the n value is. That stinks. Is there anything other than this formula that also contains an n value for geometric sequences? Well, I still don't know the n value though, right? And I'm not plugging in 125 just because I see a random number that's left over. What about the one Nora we used yesterday? Doesn't that have an n value? Okay, don't use it though. Just watch me use it, and I'll show you why I'm not going to have you do it this way. Here is our formula from yesterday for any term in a geometric sequence, right? All right, let's see if my discussion at the beginning of class did anything. What could I plug in on this problem for an? A random term, 125, right? First term? 2,000 times what? 1/2 to the, that's what I'm trying to find, right? What is that? Where's 125 in the sequence? That's what I need for n. Here's the problem. And I would not have you do it this way. To solve this, you got to use logs at the end. Oh, remember those from last year, huh? That was pain. I'm not doing it. I'm not going down that road. Okay, I am not going down that road to solve for n and have you guys use logs. So how am I going to have you guys figure out what n is? Unfortunately, we're going to go old school. All right, old school. Where is 125 in the sequence? Let's find out. What's the first term? Ready? Here we go. What's the next term? What is it? What's the next term? 1,000. If you don't know where we're getting this from, you better ask, because I'm asking somebody what's the third term. 14. Ava, what's the fourth term or third term? 500. 250. 125. Oh, found it. Right? So that's the way I'm going to have you do it. It shouldn't be that obnoxious where you don't hit it pretty soon. So what term is 125? Fifth term. There's your, so you're going to find the sum of the first 5 terms. And there's your n value. Okay. Again, yes, could I use that other formula from yesterday, but I'm not stopping and reviewing logs. It's too much of a headache. Let's do it when we review for the regions. Now you can find the sum of the first 5 terms. What a mess that would have been. So if you don't have the n value, which you won't on your delta math coming up here in a couple minutes, write out all the terms you can until you hit the term you need, and then figure out what term it is. How's 3,875 look? Good? Questions? All right, 2 word problems, and then you're going to go hit up the delta math right away. Oh, Paisley. 8 miles the first week, 5% more each week. 18 weeks. Here's the big key here. Some of you guys missed this on the quiz. Total miles. If you guys start busting out this formula from yesterday, the only thing you would be finding is how many miles she runs in the 18th week. Okay, that's what using this formula does. If I want total, I need sum, the sum formula. So let's do it. The sum of how many terms here? How many terms? 13? 8. Good. 8 weeks, right? Equals. All right. How about week 1? What's the deal with week 1? 21. I'll do that one. 8. What do we have? 8 miles on week 1? No, hold on. Where's no. We're not finding the sum of the first 8 terms.
We're finding how many.
18. Is that what you said? All right. Sorry, Liz. Sorry. 8 is my first term. Sorry. 8 minus 8. Ooh, what's the issue we have in the word problem? What are we very, very unsure about?
It's a percent and not decimal.
R value, right? I'm going up by how much? 5%, but I don't put in a 5.
Put in 0.05.
1.05.
We got some arguments here.
I know.
Whoa, let's check it out. Ready? How many did she run in week 1?
8.
Okay. She ran 5% more the next week, right? So it's got to be, everyone agrees it's got to be bigger than 8, my next term.
Yes.
Okay, so if I multiply by, what's 5% as a decimal? 0.05. Did I run 0.4 the next week?
No.
That's ridiculous. Ridiculous, right? So what do I need to do to the 0.4? Okay, so what did I actually run? 8.4. But I don't get that number just by multiplying by 0.05. So my R value cannot be 0.05. Instead, when it's a percent and I'm increasing, it's going to be 1 plus the percent. All right, 1 plus the percent. All right, so my R value is going to be 1.05. Ready? 8 times 1.05. Boom, 8.4. That's what you're multiplying by. Anytime you increase, you do 1 plus the percent. And hey, let's just say we do a decrease one next problem. What do you think I would do to find the R value instead? 1 minus your rate. 1 minus the percent. And what am I, going back to you guys now, what am I raising this to? 15. Logan, what am I raising this to? 8. The 8? You sure? 18 terms. 18 terms. Over. Redeem yourself. What's the denominator look like? 1. There you go. Let's find out how many total miles Paisley ran. Total means sum. And there is rounding directions here. I know usually we haven't done problems at all this year yet with rounding directions, but it's here. Nearest whole number. I don't have my calculator anymore, so what do you have?
225.
That sounds good from first period. Yep, 225 miles. I should have went over this at the beginning or asked you guys how I knew it was going to be geometric versus arithmetic. Anytime you go up or down by percents, it's always geometric. Because arithmetic is just same number every time. Okay, you and your group. Boom. Number 6, call me over when you're done. So I can check it. And then you go right to the Delta Math or last night's book assignment.
Okay.
Wait, so it's us 20?
No, I think since it's decreased by 5%, it's since it's decreased, I think we subtracted the 0.05 from the 1, and you get 0.05 as your R values. But then, okay, wait. So I'm not sure yet. So the value you get. Okay, yeah, it's 0. It's 0.95 because then. Yeah.
Alright, so it wants to know.
First 20 years, so that's
Whatever 1 minus your whole.
132
minus 1 minus 0.0.
So it's 1 minus
times
1.
0.95. So, and then
Decreasing is 1 minus.
Yeah,
Increasing is
0.95
I can't.
You're right.
because that's the R value. Yeah. It's the R value after you subtract stuff. And then, and no, it's also to the nth power. So I think we have to.
Or last night's before.
Yeah. So it's like to the 20th power. Oh, and then
I'm so
over
sad about my calculator.
1 minus.
The batteries exploded at the beginning. I think they were just old. I borrowed hers on test days, so she needs it usually. Okay, I have. She wrote in.
Wait. I might have been wrong. I feel like wait, is it the same board?
Oh yeah.
Yeah, I got a really big report. I think I might have been wrong.
Wait, so you the R? Well, actually, 20 years.
No. There's a bunch of numbers here.
Oh, it goes down?
Should be in the 1 year.
Yeah, it's supposed to be. Well, he just said it's
Everything is
supposed
set
to
up
be.
correctly.
It looks like it increased by 4.
Yeah, you got 6 numbers.
Yeah, I think I might have done the R value wrong.
I assumed the R was and is there
I don't know if we did this right or not. I might have made a
Go on to
mistake.
the Delta Math.
Oh my god, I got it.
You like that?
No, but you're doing the total. But you guys, you're doing total though. Right? So year 1 all the way to year 20. You're adding all those years
And even though
together.
it's decreasing, it's still getting added together.
I didn't know that.
Should be a
It's not. It's
You know, you guys are thinking that you're finding the last year. No, you're adding all the years together.
everyone's
Oh, yeah.
Into the
I
year
forgot that
1
we
minus.
were like,
And you're so much bigger than
So it's
Oh yeah.
Let's get to the Delta Math if I give you the okay.
1,527.
Yeah, that's why.
Yeah, I think so. Because you just said it were good.
I think
It's a real number, yeah. It's like 4 or less, a little less, 5, 4 or more. I don't know what. 4 or less, 4 or more. Why do I want to say it's like shut the front door? Like, that doesn't even make sense.
Okay, let's get right to the Delta Math.
4 or
Nothing
more.
else.
It's a 3 point something.
Should be geometric series.
2.5.
Geometric series.
I don't see it. It's the first and they took away our calculator on here.
It should be good because you're adding up all the terms.
I think it was 6.
1,692,000. So you're Delta Math. Remember, when you're doing the sigma, the entire thing's got to go in the parentheses.
So, is it 2%?
Yeah. But just remember, that parenthesis your calculator gives you, that whole thing's gotta get plugged in there. Don't go outside it.
Never know what's happening.